So let's go ahead and talk about the problem of the day. Be sure to answer the questions I ask out loud and think about how your work is the same or different from what we talk about together. How can we represent this problem? Say it out loud. Right, we have to show that we're comparing 7/9 for Maria, and we're comparing that to 5/6 for Juan. We can just put a blank in the middle with a less than, greater than, or equal sign, but we're not sure which of our two fractions is equal. That's what is greater. That's what we're trying to figure out. Okay, so this is a situation where both fractions are greater than a half. So our strategy we used yesterday of comparing on a number line with half as a benchmark probably won't work. Last year I had a student tell me that it was helpful for them to rename fractions as equivalent fractions with the same denominator in order to compare them. So I thought we might try that out together and think about why that might work. So how could we rename 7/9 and 5/6 so that they had a common denominator? Say it out loud. Right, we could rename them so that they both have a denominator of 18. 18. So think about the multiples of these two denominators. Why would 18 make sense as a common denominator for those two fractions? Say it out loud. Right. 18 is a multiple of both 9 and 6. So we can rename both of those fractions as 18ths. Okay, what do we need to multiply by to create a fraction that is equivalent to 7/9 but has a denominator of 18? Say it out loud. Right. We have to multiply both the numerator and the denominator by 2 because 9 times 2 is 18. 7 times 2 is 14. So 7/9 is equivalent to 14/18. When we're renaming fractions as an equivalent fraction, why is it important to multiply both the numerator and denominator by the same number? Say it out loud. Yeah, we know from our previous lessons that multiplying both the numerator and the denominator by the same number increases both of them by the same amount, and that results in a fraction that is equivalent or equal to our starting fraction. Okay, great. So what do we need to multiply by to rename 5/6 as a fraction with a denominator of 18? Say it out loud. Yes, we're going to multiply it by 3/3 because 6 times 3 is 18. 5 times 3 is 15. So 5/6 is equal to 15/18. Okay, so which fraction is greater, 7/9 or 5/6? How do you know? Say it out loud. Right. 5/6 is greater than 7/9, because 7/9 equals 14/18 and 5/6 equals 15/18. 15/18 is greater than 14/18. We know that Juan ran further. Okay, great. So I'm curious, why was it helpful to rename our fractions so that they had the same denominator before we tried to compare them? Say it out loud. Right. It's helpful because when fractions have the same denominator, then we know they have the same total number of parts. And we can then just think about which fraction has more parts that are being referred to, or the numerator. So, in addition to comparing fractions by using a half as a benchmark, what is another way that we can compare fractions? Say it out loud. Yeah, we can compare fractions by creating equivalent fractions with the same denominator. Read this with me. We can create equivalent fractions with the same denominator to compare. And what did we need to think about when we were trying to find a common denominator for our two starting fractions? Say it out loud. Yeah, we have to think about a multiple that both denominators have in common, and then multiply both the numerator and the denominator by a factor to get that new denominator. Read this with me. What multiples do the denominators have in common?